To understand the sorting problem more deeply, let's consider this game called Puppy, Cat, Dog. Now, I'll warn you in advance, this game is going to quite possibly make you feel dumb because it feels like it should be easy, but it's actually hard. Something about the thinking, at least for my brain, isn't natural, but here's how it goes. So Puppy, Cat, Dog is played as follows. We have 3 boxes, A, B, and C, and we're going to load up our puppy, our cat, and our dog into one of these 3 boxes, and we want to figure out which one is which using a scale. So each of these boxes is opaque, we can't see inside. There's no sound coming out of it. The only way we can get information from it in our thought experiment here is using a scale. And that'll tell us which one's heavier than the other. And we're going to assume that the puppy is lighter in weight than the cat, which is lighter in weight than the dog, and we'll say their weights are all unique just to keep our thinking simple. So let's imagine that we'd use we weigh our 2 items, A and B. So we take this box A and this box B, and we find that A is indeed less than B. So B is, in other words, bigger than A. And let's say we also find that B is less than C, or equivalently, C is bigger than B. The question is, which is which? Okay. Well, hopefully it's clear that A is the puppy, B is the cat, and C is the dog. So in other words, if we wanted to sort these 3 boxes, the sorted order is A, B, C. Okay. Now how about next up we have the opposite happens, right? We say that is A less than B? No. Okay, B is bigger than A. So B is bigger than A. And then we say, is B less than C? No, C is bigger than B. Okay, so in that case, C is bigger than B is bigger than A, and so if we say which is which, we have the opposite order, that C is the puppy, B is the cat, and A is the dog, right? Or in other words, the sorted order is C, B, A. That's what these orders tell us. Okay, question for you to see if this game makes sense, and this is where it's going to start making you feel dumb. The question is, which is which if we find that A is less than B, but B is not less than C? Okay, so really think about this, right? Because there's no reason to watch me do this, it'll just be confusing. So really think about this one. I think it's a pretty approachable problem. Okay, so it turns out it's a little bit of a trick question. So there's actually 2 possible answers, right? So if we say that A is less than B, and B is not less than C, there's actually 2 possibilities. So all we know, okay, we know that A is less than B. These are the 2 answers consistent with that hypothesis. And we know that C is greater than, so we know that B is greater than C. So both of these have the properties that B is greater than C and that A is less than C. And there's no way, these 2 measurements only resolve it down to the level of specification of these 2 items. It's kind of interesting, right? You didn't really think that asymmetry was going to happen, but as we'll see in a diagram soon, it just had to happen. But I hope that makes sense, right? There's 2 possible things consistent with this ordering, and so, just spoiled. So the question is, what question can we ask to resolve the ambiguity? Okay, well, so I guess it's pretty natural here. So if we wanted to resolve this ambiguity, what do we know? We know A is less than B, and we know that that B is greater than C. But what we don't know, if you look at these 2 and you think, what do we not know? We don't know how A and C are ordered. So we could ask the question, is A less than C? If the answer were yes, then the answer would simply be A, C, B, or puppy. A is puppy, C is cat, B is dog. It would be this row right here. Okay. So if you're feeling a little like, huh? How is that like trickier than I expected? That's just kind of how it goes with this. Like, don't feel bad about that. Maybe even just go do that exercise again. Maybe not right now, but I don't know, an hour or something. Okay. So we can actually draw out a decision tree. And this is basically if you wanted to write down the instructions so somebody who'd never played the game knows how to win. So you'd have them give them a card and it would say at top, ask is A less than B? Or in other words, take A and B, put them on the scale. Oops. And if the answer were yes, well, you still have to ask another question. We ask, is B less than C? If the answer is yes, then you know the answer. You know that A is puppy, B is cat, and C is dog. Or in other words, in sorted order, they're A, B, C. Now, if the answer is no, that's actually the problem we just ran into. If the answer was yes, then no, then we actually have to ask another question to resolve the result. So if the answer is yes, it would be exactly what was just on the previous slide. We have A is puppy, C is cat, B is dog, A, C, B. If the answer is no, in that case, it's C is puppy, A is cat, B is dog. So it just tells you which order A and C should go in, right? That's what this question tells you. On the other hand, we also have the no side of the tree. I'm not going to show it. You can derive it. Maybe it's a fun exercise. And this right here is everything you need to know to win the game of puppy, cat, dog. So a question for you, given what we just learned here, maybe look at this diagram. This is a pretty challenging problem. But the question is, how many questions, right? How many weighings? How many times do you need to do a weighing measurement? Do you need to solve the puppy, cat, dog, walrus problem? What's that problem? It's the same thing, but now with 4 creatures instead of 3. And the question is, well, for puppy, cat, dog, we had to ask 3 questions in the worst case. So the question is, for puppy, cat, dog, walrus, what's the worst case number of questions you need to ask to definitely solve the problem? I guess I'll put this diagram up. It's probably more useful for thinking. And it'll probably take a little time to think about, so give yourself a few minutes. Okay, so if we had puppy, cat, dog, walrus, here's the trick. So with cat, there are 3 items. Sorry, with 3 things, there are 6 permutations. But once you add a 4th item, there are now 4 times as many permutations as before. So in other words, before we had 3 factorial, now we have 4 factorial. So there's 24 total permutations. Now, since each of our decisions is on a binary tree, we need basically a hierarchy where we ask a bunch of questions, and at the bottom, we're going to count the number of leaves. Those are the number of resolutions. So for puppy, cat, dog, there were 6 leaves. For walrus, there'll be 24 leaves. And so the question basically amounts to how many, if we have a binary search tree, or sorry, not a binary search tree, a binary tree, how many levels do we need to have 24 leaves? So we can compute the log base 2 of 24 and get 4.5. And we have to round up because you can't have like part of a level. And so the result will be 5 is the minimum. Okay. So in other words, we could have done it for puppy, cat, dog and said there's 6 leaves. So to deal with that, we need log base 2 of 6 levels. And we see that, okay, so that's 2.5 levels roughly, but we don't use the entire levels. Wait, is that right? 2.5 log base 2 of 6. No, let's a calculator. Log 2 of 6. It's 2.58 levels. And so we have to round up, right? So we didn't use all of that 3rd level, but we have to, that's just how many we got. And so with puppy, cat, dog, walrus, the question, or we get the same thing, it's around 4.5. And so we get 5 as our minimum. Okay. So that's the heart of the argument we're going to use for sorting soon. And I'll talk about that a little more in the next video.